All right. So before the break, we looking at functions. What probably should have been general review. You'll get some practice with it with the homework assignment as well, and obviously you want to get practice, right? Coding takes practice, so make sure you're getting lots of practice. Projects coming up this week as well. We should probably talk about that. Got some new stuff to talk about with functions, but let's talk about the project real quick because I did not put that on the list for tonight. Project proposal. We're up to week 3 now. Oh, discussion board. I should probably mention that because some of y'all will get on the discussion board early. Please note that there are 2 due dates for the discussion board. The intro discussion board didn't really have, it was just due by the end of the module and stuff, right? Those, not as strict on those, but on this week's discussion board especially, there's going to be 2 due dates. And if you miss the first due date, so your post is due by, I want to say Thursday. It could be Friday. Let's check.
I think it's Friday.
Okay.
It was
Yeah, you're
the last one.
yeah. If you don't get your post up till, if you miss the first due date on the post, then that is still some points off on the late penalty thing. And then yeah, the replies are when the discussion board shuts down. So this week is the prompt engineering. I found that seems to go over best in discussion boards. So you want to be familiar with technology. You have a scenario here. Has everybody used ChatGPT before or something? I already flipped away. Okay. I did not. Sometimes I ask you all to use the same one, but I did not in this case. I'll go to ChatGPT. Maybe you want to use one of the newer ones you haven't tried yet. There's a lot that have come out in the last couple of years. Google Bard isn't one that's connected to Google search stuff, so it'll be free for probably indefinitely. I hope this knows my pass. Okay, yeah, you remember me. I have no idea what my password is. Unless I did this last time. I might have did this last time. Okay, yeah, that's what I did last time. We go over here if you haven't used chatbots yet, put in a prompt. It's an overblown version of the customer service chatbots. Same technology, just larger scale. It writes more. So you want to treat it like a conversation. It's not like the traditional fact page searches where you're trying to get really, really close, right? The best you can do is like a fuzzy finder on whatever's written on that fact page. It is conversational. So oh no, they're good for writing code. You write a Python static class or a employee real quick. That's a good classroom example. Oh, do you have a question, Connor? Oh, what? This one. Waiting on the chatbot to type up a response. What's that? Just oh, yeah. Oh no, we just came back from break. Sorry. I got them using ChatGPT or some chatbot in the discussion boards this week.
We're doing ChatGPT tonight too.
Yeah, this is the week.
Data and AI.
Yeah, the week it's required. So it gave us some stuff. And you want to have a discussion with it, ask how to use it, employee ID, name, position, salary. Oh, but it's conversational. So that looks, you want to treat it not like a search, like you're talking to somebody. That looks pretty good. But can we get and a hire date field as well. And then modify the code. So it's pretty good at writing. You have to get kind of specific, but it'll write that. Thank you. Just needed a quick example. But stuff like this. It processes for last night. Yeah. You'll want to go in there, take the scenario I wrote, go over there, feed a few things in, give tries, because as you ask as you prompt it in different ways, you might get slightly different responses. And that's what this is about, hence the title Prompt Engineering. You want to look for what gets the best response from it. What little tweaks to the way you ask the question give the best response. And then that's really what the discussion is. So you'll share some of the prompts and results you got with your classmates, and then the replies and the back and forth discussion part is over what worked, what didn't work, and looking for improvement, because we're going to use those sort of tools. These have been around longer than a year. This one was just started. They marketed it last year. It's been around for a while. But customer service chatbots, people have been interacting with those for a while. And for years and years and years, I've been promoting things like this for writing code, because making typos is a human trait. The intelligence part isn't really true. We don't need to dig into that too much. We're in Python, so we'll probably make one. The AWS lab that I used previously to make the little phone customer service chatbots, they got rid of that lab, and I haven't found a good one to replace it with yet. But if nothing else, we'll do it from scratch at some point near the end of the semester, because we're in Python, and most of these sort of models are written in Python. So we definitely want to make one in this class. You might not do the ones like this that will be writing full essays, but there's a pretty good chance you're going to write a customer service chatbot at some point in your software development career. So want to see how to do that. And really the work for that sort of thing is mostly data analysis. So both groups of people taking this class should probably see that. I forgot to look at the due date, but whatever the due date is, make sure you make your post by then, because there is a late penalty if you don't look at that one. Module 3, another big thing this week is your final project proposal. So click the link to see the overview of what it's about, like how many classes you need to require, what's required, what's deliverable, all of that stuff. And for project proposals, I'll probably put it right in this instructions. I usually do. In real world, I like to do it all from scratch. Not a big fan of templates, but in a classroom, templates are great. That's a document that tells you what to write and where to write it at. So a wonderful learning tool. So that's what I'm going to ask for your project proposal. Go Google free project proposal template. Google free project proposal template. Make sure you Google free. Do not pay for anything in your homework in this class. You shouldn't have to pay for anything in the homework in this class. Whenever I teach this online, last couple of times I taught this online, they use, I replaced it, it's in module 5, but they use something that on the homework assignment requires people to enter their credit card information. So that is the first thing I get rid of when I start customizing that online shell, which if some of y'all have had a bunch of online classes, you've probably heard instructors say, we can't change it. We can change it. The only thing we're not allowed to change is the point value, but most people get confused and lose track of things. So they don't change it. I do. I tend to change them a lot, but the very first thing I change is that I don't change them as much as the class I do for like on campus classes. I change it quite a bit. And first thing I change is that assignment that requires you to enter credit card information because it's a homework assignment. If you ever have to pay for a homework assignment in my class, do not do that. Reach out to me and let me know because that was an oversight. I will replace that assignment immediately. But for the proposal, think about what sort of project you're going to make. A small application. That's the thing. We're going to see it on Wednesday. We'll do our first Django one with a small, probably a tip calculator. Right? One thing that has confused people before is we are making a web application, and several times since the 200 level courses have switched to frameworks, the modern way of making software, people seem to misunderstand and want to make a website. I've actually had a couple people that spend all kinds of time on the static pages of a website that the application would just go on. And then they didn't do the actual application part that would be done in Python or Java. I just need the application. I don't need the rest of the site that it goes in, just the 1 or 2 pages for the application and the output of it. So some HTML input forms for your GUI. So it runs in a browser, and then we'll process it with Python, and maybe a second page to spit the output back on. I just need the application. I don't need a website that application would go into. I've seen people misunderstand that since we've switched over. This is the modern way of making software development. Before we get to the proposal, I'm going to jump up here to assignments. Because what we do, a bunch of y'all are using VS Code, right? VS Code is a web application. If we take off everything below, like this little gray line here, or above this line, right? Take off those tabs and the address bar. This would look like a desktop application. So basically, that's what we do. We make a web application, and then we get rid of the tabs and address bars so people can't go to any other websites but the one the application is on, and then launch that as a desktop app. So VS Code is a web application. Or if we go to like GitHub, oh, it's already on the list. I don't have to search for it. And choose one of these. Any of them work? I just need to get this button. If we go here, on the web page, it looks exactly like VS Code, works the same version on GitHub as the one on your desktop. And that's because it was actually created to be a web application. When it was created, that was actually when it was created, that was the nice thing about it. VS Code doesn't do anything that any other text editor would do. We have the same functionality in pretty much all of them. But when it was created, it was a really nice one online. But this behaves exactly the same as the one on your desktop because that is a web application. Modern way of making software has been for almost a decade now. It's been well over 50% since about 2015. It was obviously moving that way before then, like 60, 75%. 2/3 to 3/4 of software has been made that way since 2015. Academia is kind of slow keeping up on it. But in the final project submission, I did make a video here walking through the other steps using what's called the Electron framework with Node.js. Copy and paste that code. It is very much boilerplate code. Follow along this video and type that code, and then you'll copy and paste it. And there's like 3 or 4 lines that need change for every project you do afterwards. But it requires a bunch of other languages, so it's kind of hard to justify covering that in a Python specific course. But when you get to the end, this is a short video. How long is it? 25 minutes on how to turn a follow along code on how to turn a web application into a desktop application. So I did want to go ahead and take that last step. So think of an application. Think of a desktop application if that helps. What sort of application do you want? Think of a desktop application because you're going to submit it to me in a browser, but then on the submission page is a video of how you would turn that immediately, how you would turn that web application into a desktop application, which really just, we launched it in a browser that doesn't have an address bar, so we can't go anywhere else. Can't go to any pages except that one. It's not a complicated process. And for this week, I'm going to look for project proposals. Canva, for a long time, Smartsheet was above Canva, but recently, within the last year, Canva surpassed Smartsheet. If you've used Canva before, that'll make a great looking proposal. They have some nice templates on there. However, if you haven't used Canva before, there's a large learning curve to it. Makes really, really nice looking things, but there can be a large learning curve at times. Getting to make things look really, really nice. So if you haven't used it before, probably go with the traditional templates. If you know Canva, go ahead and go on there. It's become popular enough that other software is going to be copying what it does soon. So when time allows, you might want to go on Canva and start clicking things around. But for us, we can just go to I've been using this one for a while, Smartsheet, 17 free proposal templates. Basically look through here and choose what colors you like. Find one of them and then fill out this proposal template. But I'm going to ask that you do a couple extra steps. Need to download. So I'm just going to go with this first one, which opens in Google Docs. A lot of them do, and they have this nice little picture. But if you have a template that opens in Docs, you want to make sure and make a copy because the template itself won't be editable. This one will be. We get a copy here. And just kind of fill this out. Don't need the instructions. So, SDEV 220 final project. You'll know what you're making for some of this, right? Some software created in Python. You'll have a much better description for what you're making. All of that, and all of these things we would be expected to turn over to a client in the real world. Did I talk about plans in here? I can't remember if I did or not. So anything, I will be very quick to agree, anything that fits in the time constraint of a classroom could probably be made without a plan. However, the contrapositive of that is also true. If we spin that order around and switch the negation, anything that fits in the anything that fits in the time constraints of a classroom is easy to make a plan on. The contrapositive is also true. If it fits in our time, it is easy to make a plan for anything that fits in the time constraints for our classroom. In certain parts, you want to get some practice with. In particular, these two lines right down here. Because in the real world, you're going to fill out proposals like this, some of them much, much longer, some of them shorter. But ultimately, there's only two lines people care about, right? When do they get it and how much does it cost? And there's only one way to get good at those two numbers, and that's practice. How can do that in a classroom? We'll start off this. In a classroom, those two numbers are as trivial as can be, right? Project schedule, March 10th. If you have it any later than March 10th, it doesn't get accepted. That's the final cutoff for the semester, right? That's as trivial as can be. Day to day, our examples, it's got to be done by the end of the class. So a classroom's not a good spot to learn that. And the classroom, our budget is always this. That's always our budget in the classroom. So that's not good practice for it. But you want to try to get good at predicting those numbers. So break things down, right? So what I'd like to see on those two is with the schedule, give some sort of breakdown. This due date for this is the 5th. So February 5th, submit proposal. February 16th, have data classes. Have classes and objects created. February 22nd will be a good goal there. Yours will obviously be more detailed because you know what you're making, right? Have database created and filled. By March 1st, have a style sheet in place. By March 5th, finalize everything. I don't know, something like that. And then it's ready 5 days before. But break it down on a timeline like that. And on your budget, do the same thing. Obviously, no money is going to change hands for a homework assignment, but saying that the budget is 0 is not good practice for you, right? So what you want to do, I don't know, $75 per hour times 32 expected working hours equals, I probably could have chosen numbers that were easier to do the math on. 75 times 32, 2,400. So, right, it's a $2,400 project, but then for business reasons, we might want to add business expenses. So, like depreciation on a computer and all that stuff, we'll add another 400, which brings us to a total of 2,800. Break it down. Come up with some hourly rate, and then keep track of these things. And your business expenses, you're just making up, so you might not know those precisely yet. But your early estimate, it's gonna take 32 hours to put this together in total. Spread out over 6 weeks. That's what, 5 hours per week. That's kind of heavy. Probably should flip those numbers. 23 hours to put the project together. Spread out over 6 weeks, that's less than 4 hours a week. And that would include time like thinking about what to do. The planning time, not 4 hours a week typing. That includes thinking about it, debugging it, all of that. And try to then at the end of the semester, make note of how far off you were. It's like, oh, I didn't get that done until the 18th. But then that next step I had ready the following day. So make a note of where those were. So then on the next project, you can quickly jot down some notes and get a better estimate of that. And then by the time you get out and are ready to search for a job, you'll be much better at guessing those two numbers. Because the industry, the standard is a lot of people, they bid high. They say it's going to cost more than what they expect and take longer than what they expect. But if you do that without planning, do you really know if it's more and longer without thoroughly planning it? If you bid make that too short or make the bid too low and you have to raise the price, people are going to get upset. But if you get in practice in the classroom, because it's really easy to do for anything we do in the classroom, right? You doing your homework assignment, be like, okay, I expect this to take me 20 minutes. It takes 28 minutes. Make that adjustment. So the next one you think is about the same. Be like, okay, I'm going to say 25 minutes this time, and refine that estimate. The assignment after that, just do a quick estimate. Be like, okay, this is much harder than last week's. This is going to take me like 45 minutes. And then come up with a money map thing, make an hourly wage and come up with a bid for that. And just through practice, it only takes a few seconds on each thing. You'll get really good at predicting those two numbers. Every time you're going to fill out this entire proposal or longer proposals, some of those templates got kind of long. But when it comes down to it, you'll have all that stuff, but there's only 2 lines people care about. When do they get it? And how much does it cost? And if you are good at predicting those lines, people will take notice. Clients will take notice. Coworkers will take notice. Managers will take notice. It could be people on a different project that you're not even working on. They might just start asking for advice and want to reach out to you as a consultant for that. But get practice on those 2 numbers. It will make a huge difference in your career if you can do those accurately. And that's what's wanted for the proposal, right? Fill out the rest of that, but make something up for those two spots because those are the ones you want to get practice on. Yeah, I think that was all I wanted to say about that. You can read through the thing. If you have any questions, let me know. If you're having trouble thinking of ideas, let me know. We can talk about some stuff. On Wednesday, we will take our first look at Django. We'll probably do a small tip calculator, either a tip calculator or a payroll calculator. And whichever one we don't do for Django on Wednesday, we will do for we will do with data structures in a couple weeks. So yeah, those make good examples. Most people in America kind of understand the basics of the basic idea behind tip calculators and payroll calculators. So then we don't have to spend a lot of time explaining the math. We can focus on the coding part. Any questions about that before we get back to the rest of our stuff from this evening?
Yes, for that assignment, for the final project proposal. It's just that those few little parts that you just went over with us. It doesn't need to be like a full scale.
Yeah. Oh, fill out the whole template. So get one of those project proposal templates.
Yeah, I was just more or less like the filling out it. We don't have to write the code right now.
No, the code's not due till the end of the semester. It's going to be a Django project, so there's no way, unless you're going to be bored out of your mind during this semester, you probably don't know how to write the code for a Django project yet. So yeah, just tell me what you're going to make, and then I will either approve it or give comments. But I've been teaching for years, and I was telling my afternoon class this. I was telling the class this afternoon. I was trying to think back, and I don't think I have ever rejected a project because it wasn't big enough. Most people think things. The projects that I've had to be like, that's not going to work, or because they're way too big to fit in our time constraints. Like for our classes, like there's no possible way you're going to do that in the next 6 weeks. If you try to turn in an idea like that, yeah, I'm pretty sure that's the only ones I've ever rejected is when the idea is way too big to fit in our time. I don't remember ever having somebody try to propose a project that was too small for the class. Most people think big. They have lots of ideas in plan, but I will review it and try to get back to you quick. So you don't have to wait till the due date to turn that in. If you know what you're going to make, if you know what project you'd like to make, go ahead and write up the proposal, and I'll. That's one assignment I try to grade them as soon as they come in. Some assignments I try to wait till there's 5 or 6 of them so I can grade everybody's at the same time and make sure I'm being consistent with it. But project proposals, I'll try to grade them as quick as they come in. That way you can get to the feedback on what changes to make or things like that. Any other questions about the proposals? Okay. I assume 5 seconds is enough time to reach over and unmute if you have questions. If any show up, let me know. So we're going to look at some other stuff about functions. So let's define a function. Inside, I'll call it that. And I'm going to set up a parameter. I'll call it that way. No, actually, I just want a parameter here. Stuff. We're going to pass some stuff in. I'll put a condition here. If length, I'll do type. Did we do it? Is instance yet? is instance. It returns true or false if we have a certain thing, so we can check if a string got passed in. If you're in Spider, Control I opens your help menu, will open the documentation right here. I'll use this, but notice there's two things. The object, what are we checking? We want to check stuff, and we want to know if that's a string. If it is, print hello world. Otherwise, I'm just going to skip the else. And my indenting seems off. There we go. But now, instead of doing something here, I'm going to define another function. Actually, I don't want to put hello world there. That will work. Define some sort of other function. I'll just call this nesting. So a nested function here. Notice there's no parameter here, but we'll print stuff. Then I'm going to come down and call that function here. And then it got off. I have found it's best to let Python handle the indenting. So I'll come down, unindent to get past that function, and then I'm just going to call that function. That looks a little bit different, right? So that's a nested function. Everybody's seen nested before, right? We put a function inside of a function, and then we're only using it in here so we can access that variable. Actually, let me go ahead and put the else in there. Else, we'll define a different one. Define nesting as print, that's the wrong type. So we have two different definitions, kind of an extended example. So maybe not the best or most boring one, but notice how we have void functions inside of there. And then we just call that function here. Or really, I guess we call it down here, don't we? Inside. So I'm going to call that inside function. Oh, forgot the parameter. We need some words there, don't we? Have to fill a parameter in the message. One required positional argument, and we didn't send any in. So it's in that. It is a string, so it tells us that'll work and then prints it out. But if I pass in an integer, 3, it's not a string, so we get that other call. So you probably hadn't thought of it, but hopefully it's no surprise that we can nest functions. They're fairly straightforward. Notice that the nested functions are all void, right? There's no return statement anywhere in there. When we return stuff, that's when we get a closure. In particular, when we return the nested function. Define, I don't know, giving back, giving, yeah. If we return stuff, we have a closure. So giving sounds like a synonym. Again, we need a parameter that we'll pass in. Just We could do it without parameters, or we can kind of list out the parameters. Let's do 2 parameters this thing. All the trivial examples have only had 1, so if you need multiple parameters, just pass in, just comma separate it. And we'll talk about args and quargs soon. That's kind of an important thing. So I'll do stuff needs to be a word, and then, yeah, send in things, number for that. So I'll print one of them out immediately. That seems like a good thing. And then I'll put a nested function that we can use the other one in. Changing. So we'll use that stuff variable and reassign it. So I need to return things on it. Modified equals stuff. A string is an array of characters, so we can always sub-index a string. That's across the board in all things. If you can't remember the method name, a string is always an array of characters. So you can just go in that way. Let's say from index 1 to index -2. Everybody's seen that before. Try to shove a bunch of things in there. We left that out last week. We can the colon, and we do 2 indexes, and that's like a sub, just part of the list. So treating a string the same way, we're going to go from index 1, which is the second character in the string, and Python allows negative indexing, so we'll go to 2 characters before the end. Then we'll return modified, and we'll return changing. I think I want the parentheses there. We will see before long. Sometimes our callbacks, we need the parentheses, and sometimes we don't. So ultimately, it comes down to trying it out and see whether it works or not. You see the difference between closure and nested? Right, we had the return and void functions. Nested functions are all void functions all the way through, and closures are returning stuff. That's something we have in most of our languages. Closures are used more often in Python than others. Some other languages, but there are availables. When we do decorators here in a second, you'll see sort of a common thing. It allows us to do multiple things at once. So closures are especially useful for logging, or maybe checking signatures on which developer, right? We have a team of 30,000 programmers. We want to know who made each function. So have signatures in there, or for all the stuff that the function is supposed to do. And then we want to log it to a text file somewhere along the way. So closures are really nice for that as well. We can separate out the logging. What I call that, giving. So it's a return function. So I need to either assign it to a value when it returns, or print it out. I got to do something with it. So I'm called a giving function with some words. Here are some words, and then maybe a number, 17. So see, we've got the 17, and then we started at index number 1 and stopped 2 before the end. 1, 2. So be careful with that indexing. That's why I was careful to point out last week. Right, ask from the beginning, count from the end. So it moves differently if we use positive or negative ones. Because notice how much went away there versus there. It's not -2 from the length. It's -2 from the index. Might be a better way to say that. But that's a closure. So different types of functions we have. Closures probably show up more than nested functions. as we move forward, because of callbacks, it'll kind of be important to do those. The last one I want to look at is just a useful function, a useful way of setting them up. And that's with what's called decorators. I'll put that here. Decorators. And I need to import a module. Moment, so I don't remember which module it is, so I'm going to quickly refer to things. So we've been doing Google searches, right? Half the time I do that on purpose, right? Because that's what you all are going to do. But this time let's do something different. Let's jump over to GitHub, and I'm going to look at SDEV 220 from spring 2023. Last time I taught this course. This is something you might want to start building up to. Instead of going back to arbitrary reference material online, start building up start keeping track of your code in a way that you can refer back to your own code very easily. So I'm going to look at what we were doing this last year. And the reason for that is when you look at your own code, you will see a lot of things. It'll trigger other memories. It'll trigger other memories of what was going on at the time. So it works better than just looking up the one line of code, because you'll remember what you were doing when you originally did that. There it is. Function tools. Func tools. I can't remember the name of the library. Might as well leave that out just in case I forget something else, because I haven't done a decorator since when I taught this class last spring. Import wraps. So let's make a couple functions here. And look, I have a previous example, might as well, since I was talking about that. This is how we add an annotation. So notice it looks like we have a closure. Return statements, it's got to be a closure, not a nested function. And then we put this annotation in here. But the parameter here clearly looks like it's expected to accept the function, right? So it does need to be a closure. Let's go ahead and type this up. But from that point, keep track of your own code. Repositories are great for that. You can make them private so nobody else in the world can see them. But when you refer to your own code for examples, because maybe it's something you remember doing a year and a half ago, can't quite remember what you did, instead of looking up the same tutorial you found it from a year and a half ago, look at your own code, because that'll trigger other memories of what you were doing at the time you wrote that thing. So I want to define a function here. That should not be into it. There we go. That shouldn't be in it. Define a function. I'll call it signature. So this is kind of like logging, or that big thing I was talking about. If you're on a big, huge team, right? Modern software development is not one programmer sitting down and writing a few lines of code. The last two Facebook projects, the second one's about to wrap up now. Right? You remember about a year ago, the news wanting to be all paranoid, started saying Facebook laid off 11,000 programmers. It wasn't necessarily a bad thing in that case. The long way of saying that is Facebook hired 42,000 programmers. The project finished successfully. And then the next project, Facebook hired 43,000 programmers. Successful finish. They accomplished a great job, great. Might have the question of what did Facebook do that required 43,000 programmers? They didn't change their style sheet that year. They've been up and running for a while. They standardized VR. They standardized VR and AR. But they finished that quite successfully. And the following project only required 32,000 programmers. So yeah, that is the technical version of a layoff. But those people that were laid off are fine. They got nice severance packages. They have the resume looks great after that project, and all that stuff. And it took 3 years. So even if they were fresh out of school, and were having trouble finding a job before because everybody kept asking for experience, then they have 3 years of experience with Facebook on a massive project like that they can point to, along with the severance package. Those people were fine. It's not like when the typical we hear about like Ford laying off people, and a lot of them might have been living paycheck to paycheck, and those layoffs start before the next pay period. So that's different than the Facebook layoffs. But the news wanted to make a big deal out of it. But a project that big, you want to know who made what, right? There's if something goes wrong, or if something works good, or if you think something would integrate with your part, you want to be able to know who to contact. So a decorator is nice for a signature. What's that line? Oh, whoops. I meant that. Sorry, let's go back to the code and make a typo. I got distracted there. From the Funk Tools modules, import wraps. So instead of importing that whole module and then just using bits and pieces out of it, I just want that one thing out of it. So I'm just going to grab that instead of the whole thing. And if anybody knows SQL, it is not a coincidence that that looks like SQL syntax. It is as far opposite from coincidence as can be. It is SQL syntax. Yeah, it really is a SQL query when we import that way and choose things from the modules. But that's beyond the scope of this course. And when I say beyond the scope of this course, I might say that occasionally. That means it's not planned for the lecture. Doesn't mean you can't ask questions about it if it seems related to your interest, or it doesn't mean it's too complicated for what we're doing. It means it's going to burn up time we don't have. But you are still free. You are. I am still available to answer questions when I say that. But we're not going to talk about why we can run a SQL query when we do an import. We won't talk about that, but we will be using SQL in Python. You'll see that in module 6, I believe. So back to this. I want to use this annotation. Everybody seen annotation before? So annotations is shorthand, shortcuts. Because ultimately that's what we're making here. It's like, yeah, that's a lot to call these functions. I just want to, I'm tired of calling these functions over and over again. I just want to type an @ symbol and one keyword and then have the function run. I'm tired of typing the same thing over and over again. So that's what an annotation is. This is how we set those up. That's why I wanted to include them. So @wraps, and then we'll do our closure. We'll define the function for our closure. I'll call it who is it. Print. This is my signature, right? So I'll just do CS Francis. Hit this on. Plus, I guess I better import date. Import the date module. Plus cast as a string, date, date. I need date time, don't I? Then I can do date time dot now. I think I have a dot now. Go to date. Oh, there it is. Date time dot now. That's probably a good one to do the other syntax from too. So from date time, import everything. So the wildcard selector. So let's just import everything from that module. And then we can get rid of the extra date time there now. We haven't seen that syntax yet. That way you know what that means. Instead of importing one thing specific, just the wildcard character, just import everything. But it gives us we don't have to type datetime dot now. So a little signature on this. And then we want to return. Who is it? Is that what I wanted? Or did I want to return that? Yeah, we're doing closures. I meant to return that. Oh, wait, no. I'm going to print that, and then the return, I want to return that function that was passed in with args and quarks. I need to pass it in here. Syntax what? What isn't it like that? Oh, sorry. I am getting tired. I think that's what this is for. That's another reason to wrap up at 8 o'clock. I've been here since early this morning. Sorry, the asterisks go first. Args and quarks. So this is what they originally called it. We could call it whatever we want. The part that matters is there's one asterisk before this one, and there's two asterisks before this one. And that gives us a way to pass all our parameters as a collection. All of the single value things, right? X, Y, 5, hello world. The single value parameters go into args. The collection, so lists, dictionaries, all of that go into quarks. That's built into the language. If anybody knows C family stuff, we don't do a lot of pointers in Python, but we do have them. It's a pointer. You haven't seen pointers before. We're not going to get into that much. But when he originally created Python, he called it args and quarks. So we usually do that. The arguments and the keyword arguments. So single values, which really we can call it whatever we want. What matters is the asterisks. One asterisk for a bunch of single values. I collect a whole bunch of single values, and two asterisks for a whole bunch of lists and arrays and dictionaries and tuples and sets and whatever collections we have. So we just, if whatever parameters came with this function, we want to make sure and run them at this point. That's just, that's the generic filler, like whatever is there. And then I return the inner function because it's a closure. Who is it? I think with args and quarks again. I haven't done this since last year. Oh, no parentheses this time. It Zoom calls out of the way. Sorry, I haven't done. So this time the callback does not get parentheses because we do not want to run it. This one, our callback, we put the parentheses because whenever we hit this return, we want it. That's when we want it to run. Here, we do not want it to return until we do the wraps part. So you can see there's a bunch of spaces, parameters for places to go, but we're not really doing anything yet. That's a different function. So let me do define a function called double x, and then we'll return whatever 2 times x is with the double thing. So there's a nice little function we can use. Probably a bigger example is where we would want to sign that, have a big team, want somebody to sign it, the example I did here. But a similar thing with logging, right? Instead of printing that to the console, write that to the log file and then run the function. It's like somebody called this function. Somebody called this other function. It's really, really great for logs because then to call this, we created an annotation. So we say at signature. And then I have my cursor somewhere else so that's not highlighted. That is the call to this decorator function. That makes sense. Probably kind of confusing, right? This is another one of those nights that's like, oh my, that escalated quickly. Oh, I guess we better actually call that. So whenever we run the double function, run the signature, then down here, we're gonna call that function with say a 4, which I guess we better print. Well, let's run it here. We got a print in there. End object has no attribute module. What? That's not the error message I was expecting. Let me put that in a void thing. See if it gives the same error message this one. Okay, I'm gonna look back at the example because I haven't done that in a year. So there's sort of the thing we just did. There's where we put the signature on it. And there's where we call it. What did I miss?
Is the date time supposed to be a string?
It should eventually.
Because you have an int but on line 77 for the first part. Oh, sorry, no, that was print actually. Sorry, never mind.
Oh, um, let's turn it. Well, part of it is it doesn't like that. It doesn't like that syntax. We talked about that. Let me get rid of that and go back to the messy way. Whoops. What is it? Date time dot date time. That way it gets rid of that warning. Maybe it just doesn't like those. We're not really passing functions in. We talked about RT parts. We'll see them. Nope. Where? On line 56. Didn't we finish this a while ago?
Must be.
Oh no, that's the import from there. That's not from my code. Where's my code? This one. Line 112. Double signature. We did review that example. So we define our signature. Oh, I did forget something. At wraps, and then we want to say the function and put those args and quarks back in there. Okay. Sorry, I am getting I have long days. I'm gonna write that off to being tired.
Why is it still giving the little red?
X? It doesn't like args and quarks. It will be fine because it's a pointer at nothing, but the computer doesn't know that it's a pointer at nothing until it runs. It doesn't know what's in there, so it can't be like that's not okay. Int object is not callable. What? Line 78, which is the problem. I need to look back at the example. I haven't done this in a year and I'm getting tired. Oh, I need args and quarks there. Sorry, this is just here is where we need args and quarks. Now it should like it because it's passing something in. I was thinking nothing would be okay, but actually nothing's not going to be okay, is it? Because we need something passed in. But the signature should be set up for any of our things. Let me make sure I did it without any typos. Okay, there we go. I apologize for that. That one, sometimes I throw in errors on purpose to see the error messages and figure out how to fix it. That one is straight up just I'm tired. Yes, I've been busy all day long and it's starting to get late and I didn't have time to drink coffee. So I haven't had a cup of coffee since like 2 o'clock in the day. No, since like noon. That's what it is. I just haven't had coffee since noon, and normally I drink coffee constantly.
So
I apologize. That one was just typos from being tired. So let's talk about this now that it's fixed. So we're defining our wrapping function, which is signature. And notice we pass in a function, and then we'll say we're wrapping a function. Our closure is expecting some parameters, which we call args and quarks and pointers. We don't know how many are coming. It could be 0. It could be 50. They could come in as single individual values. They could come in as a list. We don't know what's coming. We just know that something is coming. Could be nothing, could be a lot. Because those will be needed to run our function, right? When we pass this in, this is our double function. And then it's a closure, so we're returning things. No parentheses, because we don't want it to run yet. Because if we put the parentheses, it would run when we did the annotation. Here's where we're asking for it. So we don't want it to run yet. That's why there's no parentheses. And the computer will figure out what time to run. It needs to run later. Sorry, I got a bunch of silly mistakes on that one. I'm just going to copy and paste. Since I already opened last year's example, I'm going to copy and paste last year's example and you look at that, let you all look at that. And then we just printed out the result, right? No surprise there, we know twice as much as 4 is 8. But the important thing is that notice that signature came in. We can do that with another function. Find triple. Add. I'll do a couple things. X and Y, return X plus Y. Add a signature to it. And if we go sign this one, are we using args or quarks? We're using the single pointer or double pointer. We have multiple values, but are either one of them a list? Samantha's shaking her head no. Yeah, so that's where args would come in. we write different number of parameters on each function that we want to put our signature on. And then we call it the same way. Print. I just forgot what I called that. I'm getting really tired. Add 3 and 4. Those are good numbers to add. But see how our signature works with any function we put in there now. That's how we make annotations to make other functions. A really useful one that instead of printing it to the console, open up the log file and write the log file and say what we just did. Very, very useful long-term debugging. Decorators are nice. Also good for timing. I'm just going to copy that from last year's example, and I will leave that for you all to read. Nothing necessarily new there. Right, so we're still wrapping a function, but we need to import time. Import time. We take the current measurement of time, run our function, take another measurement of time, and then the amount of time it took is just the difference between them. I'm just going to copy that over there. I'll let y'all look at that. That way there's some comparison, and then we can do multiple things. So we can see how long it takes to add timed. So notice how this one's going to do a signature and tell us how long it took. Or just do one quick one here. At times, whoops. Nope, I don't want the parentheses. Define a function called subtract X and Y, and that way I'm mostly copying from the line above. X minus Y. And just do those are going to be very, very quick. To see how we can do multiple annotations that way too. So if we need to do a lot of things, we can also wrap them up in annotations. Y'all want to play around with them. For start, think of log files. I just printed a signature on here, but think of open software log.txt and then write some stuff to the file, write down what the function is doing, and then close the file, save the file, all that, so that you can keep track of what the software is doing. And print subtract with 7 and 2. Oops. Oh. One type of notice how I just left the return blank. We have to call that special, but I'm already making silly mistakes from being tired, so I'm just going to run that function a couple more times on the return. Actually, I could probably just put it there. See if that fixes the error. There we go. So it took 0 nanoseconds to add 2 numbers. So we need more than just nanoseconds in order to add numbers or some sort of delay, but you can see it took that measurement. Should have took the measurement. I'm not sure why it didn't take the measurement, but the basic idea of it there. I'm getting tired and starting to make silly mistakes, so if I can give you the example much longer, it's probably going to be full of silly mistakes. I will leave that one there for you. I'm not sure why that returned 0, so maybe look at that and see if you can find where it returned 0, but hopefully all the parts for this made sense. That's a really, really common and useful type of closure that we do. But I'm starting to make lots of silly mistakes, which means it's probably a good time to wrap up the lecture. Let me go over here, make sure everything's saved in the right spot. I put those in a folder. I probably should have put those in a folder by themselves. There's methods and other methods. I'm going to put those in a folder by themselves. Close that, close that. Go ahead and close on Spider. Got these two. Here's the folder first on it. Method stuff. We got this, and I think that was the only parts of it. So they're in there. This time I'm going to go up to GitHub, and I'll just use the easy upload this time. Here's our repository. I'm pretty sure there's still less than 100 files in there. It's a 100 file upload limit. So upload a file. I want to do this at least once before we pass the 100 file upload limit. And then I'm going to grab this and drag it over. 22 files. Yeah, we're still way less
For each repository or total?
for each upload. So for the web interface upload, you can for that drag over, you can only drag over 100 files at a time. If you have more than 100 files, you have to use a terminal or one of the desktop applications. But that is a website. So, or if you have like 300 files, you just have to do 3 uploads, 100 at a time. So you can see the new stuff should be on there somewhere. Wait, where is it? Oh. It's not what I meant to do. Yeah, I was that. Sorry, let me try that again. I want to grab the stuff inside that folder and drag it over there so we don't have that folder. So ignore that folder. I will get that deleted later. Still uploading the same 22 files. And when I commit changes, yes, trying to do an example when tired is not, it's hard to do things when tired. Remember, rest is productive if you need it. But there's the 2 new things from tonight. And ignore this one, I'll delete that soon. So you can see we can use that web interface to get everything up there. Or we could, lots of different ways to get things on GitHub. I think we've looked at a different one every single class. Okay, I apologize for those silly mistakes near the end. I'm definitely attributing that to getting tired, and I will definitely make it a point to drink coffee and be in my normal frame of mind from here on out. So apologize for that. Does anybody have any questions about this stuff before we wrap up? I'll give it like 5 seconds. Okay. I assume silence means there's no questions. If you have any, let me know. That leaves us what, an hour and 20 minutes of class time. So please use it productively. And if you're feeling like I am right now, then rest is productive. Resting and then coming back to stuff when you're not making silly mistakes from being tired makes a big difference. Hopefully that didn't over confuse things. Look at the example. The examples on the GitHub page. Look at that, make sure that makes sense, because those things near the end are important ones that you'll want to use periodically. Decorators especially, but closures and decorators are a very popular type of closure. If you have any questions, let me know. Even though I'm really tired, I'm still just going to be sitting around waiting for questions to come my way until 9:50. I Otherwise, I will see you all Wednesday, and I'll make sure I'm well rested and caffeinated before Wednesday's class. Y'all have a good one.